Well, this is a $10 billion industry for power transistors. And about every 20 years, the industry transitions. And now we're seeing this transition to GaN, gallium nitride. Really, it's all about getting people transitioned over, building $1 billion company in sales in that $10 billion marketplace.
This is Energy Cast, and I'm Jay Downhauer. Today we are talking about power transistors, the little components that make up basically everything that runs on electricity. When you think of transistors or semiconductors, you typically think of this. But power semiconductors serve a different purpose. They are designed to manage considerably more power passing through them. My guess says the key to efficiency is how quick these transistors can switch. Because his transistors can switch 1,000,000 times faster than conventional silicon semiconductors, there's less heat loss and more efficiency. So what could be better than silicon? The answer, my guest says, is gallium nitride, or GaN. The technology has been around since the 90s, and it was most famously used to create blue LEDs. Yeah, that's right. Apparently, this was the key color needed to create pure white light, and without it, we would not have the LED lighting we do today. By producing fast-switching, energy-efficient power transistors, some of the most energy-intensive applications we see out there today could become cooler, faster, and consume far less energy. My guest today is Jim Witham, CEO of GaN Systems, a global semiconductor company based in Ottawa, whose sole focus is developing applications for gallium nitride semiconductors. GaN Systems was founded in 2008, and Jim came on board as its CEO 5 years ago, just as the technology was ready for commercialization. As I said earlier, these transistors can be used on just about any electronic device. So the big question for me was, where does a company like this begin to plant the flag? So far, they focused on 5 sectors: consumer electronics, data centers, renewable energy, industrial equipment, and automotive, particularly electric vehicles. I hope you enjoy my conversation with Jim Witham. We're here with Jim Witham, CEO of GaN Systems. And Jim, based on what I've read, gallium nitride semiconductors have been around since the 90s. So why are they being discussed as a replacement for conventional semiconductors just now?
Yeah, Jay, GaN was first introduced in the 1990s, so people have been talking about GaN for a while. The first products were blue LEDs. They were invented by Nakamura, who won the Nobel Prize. He's now at UC Santa Barbara. And those blue LEDs were kind of the missing link in order to make a white spectrum and make all the LED light bulbs that we see replacing incandescent light bulbs. And the second market that GaN took over is the RF GaN market. And these are low voltage transistors used in communication systems, like things for 5G. And now we're seeing GaN in power transistors taking over from silicon transistors, from chargers for phones and notebook computers all the way up to the traction inverter for an electric car. So, yeah, people have been talking about GaN for a long time and continue to talk about it today.
Yeah, and Jim, we're curious, what makes them more efficient than conventional semiconductors?
Well, there's really 2 reasons. First of all, GaN power transistors switch really fast. They switch 1,000,000 times faster than comparable silicon devices. And fast switching is important because it reduces power losses. It makes things more efficient. And then the second thing is when you switch a power system very fast or at high frequency, you can make all the components in the system much smaller. A typical rule of thumb is switch 4 times faster and the components get 1/4 the size. So with GaN transistors, you can make things more efficient and you can make the power electronics tiny.
And so there's a Moore's law with regard to semiconductors. Are GaN semiconductors cost competitive now with silicon, or will they need more time to become more affordable? Where are we at right now at this point in time?
GaN is absolutely competitive today. And it's just not me saying that. My customers are saying that also. Two examples that are out there in the public domain. One is Sonnen, the number one company in the world for solar energy storage systems. And the second is Valeo, one of the top suppliers of automotive electronics. And both have publicly come out and said that their bill of materials cost went down 8% when using GaN systems parts. Bill of materials, that's the total cost of the system, absolutely competitive today. In fact, people are making better systems, smaller and lighter weight, and reducing the cost of the system.
Yeah, look, I'd like to make people understand that we're not talking about the chips that go in your computers. These are semiconductors for more like power systems, right?
Yeah, exactly. A good example is a data center where you have all these racks of servers. The servers do the computing to take all of our internet messages and the like. And the GaN power transistors are used to deliver power from the grid down to the microprocessors. And the savings are huge. For example, data centers use about 3% of the world's electricity. That's rising to 5%, and some are even predicting 10%. And by using GaN into the power delivery system, the average data center can save $460 million on their energy costs. So there's huge savings when you use more efficient power electronics.
Jim, there's also talk about using these chips with energy storage, and anybody who listens to this podcast knows that's a topic I discuss a lot, especially with regard to renewable energy. I say you can't do renewables without storage. How would these GaN semiconductors be used for energy storage specifically?
All the solar companies are using GaN, but solar companies with energy storage, it's even more important. And that's why a typical system will have a solar panel and a bank of batteries. You take the solar energy, you charge some batteries, and then you take that energy from the batteries and deliver it to the user at a later time. Instead of traveling through the power electronics once, the electrons are traveling through the power electronics twice. So it's efficiency times efficiency, or efficiency squared, the driving factor in how much energy you're using. And so it's absolutely critical in energy storage systems to have high-efficient GaN power electronics.
We also talk a lot about electric vehicles, even though that's not necessarily electric generation, just a large part of the power sector moving forward. How would they be used in electric vehicles?
And the big application in electric vehicles is the powertrain, onboard chargers, DC to DC converters, and the traction inverter itself. That's the piece of electronics that makes the motor spin and makes the wheels turn. Overall, there's over 100 GaN transistors in an electric vehicle, so they're major components in kind of making the whole system work. And then the other marketplace is autonomous vehicles, vehicles without drivers. And you can add in application of LiDAR, where the fast switching performance of GaN transistors allows LiDAR to look out farther and to be more discriminant of the objects that are out there, so the autonomous vehicle can react to people and bikes and other cars.
Sure. Jim, tell us a little bit about you and how you came to this company and how that came about.
I've been in the power electronics industry for a long time. I made my own silicon transistors and put them into some of the power systems my companies were making in the past. I took a look at silicon carbide and I took a look at GaN and saw that you could do a lot better with your power system design by using GaN transistors. And so when GaN Systems perfected the design about 5 years ago, I joined the company to commercialize the product and have been out talking to customers like Sonnen and Valeo and getting the transistors designed into the products and really improving power electronics for the whole world.
I worked with a company that was a lot like this. They had a solid state circuit breaker. And it's one of these things where you could basically use everywhere. I think one of the challenges for those guys, and I can only imagine one of the challenges for you, especially in the early days, Jim, you could basically talk to anybody. So what were those decisions like as far as, okay, well, who do we specifically talk to? You can't talk to everybody and you can't satisfy everybody's needs immediately. So how did you parse out, okay, these are the people we're going to start out going after, and how are we going to expand from there?
Yeah, we've targeted 5 markets. Those markets are GaN power adapters, travel adapters for things like phones and notebooks. That's one. The second one is that data center marketplace because there's such huge savings in energy for data centers. The third area is solar, in particular solar ESS systems, because efficiency is so important. The fourth area is factory motors. Over 40% of the world's electricity is used by factory motors. And factory motors can waste up to 30% of the energy that's going to them. It's burned up as heat. So by using GaN transistors, you can dramatically reduce that amount of wasted energy. So factory motors is a fourth. And then we talked about EVs, huge marketplace for power transistors and GaN power transistors. So those are the 5 marketplaces that we concentrate on because really the customers can get the biggest bang for the buck by using GaN transistors.
Now, I know you're supposed to love all your children equally. Is there any one that seems to be really high growth? How do you see these 5 business sectors, you say?
Well, I think there's some trends in the world that are troubling, and that is too much CO2 in the air, which is changing global climate. And so I think that as a whole, the world, we have to go to renewable energy. And one of the biggest CO2 is our cars. So having electric vehicles that don't put CO2 into the atmosphere and having that supplied by renewable energy, I think fundamentally changes the world that we live in. So I see EV and solar ESS or just renewable energy storage systems as being the 2 critical components to make the world a better place.
Yeah. Was there any sector that surprised you? It's like, there's no growth in this. There's no business. And it was like, whoa, it really is.
Yeah, I didn't think that a place that would use GaN transistors. The motors are pretty small, and a lot of work has been done with the efficiency on those motors as opposed to factory motors. But we're seeing a lot of pull from our white goods, refrigerators, air conditioners, washing machines, also using GaN transistors. So that was a bit surprising for me.
Is there anything holding back GaN Semiconductors? Is there an infrastructure? Are there support services that still need to be built up? In a perfect world, what would you say needs to be improved to really see GaN see a major dominance?
From a manufacturing standpoint, not an issue. There's lots of capacity for GaN transistors. That's because we build our devices on silicon substrates, same substrates that have been used for 30 years by silicon power transistors. So capacity is not an issue there. We also build our devices on standard CMOS processing lines. So again, machinery that's been around for 30 years. I think the biggest impediment for any transition in power electronics is it's a very conservative industry. People need to do lots of testing to convince themselves that they want to go switch technology and realize the benefits. And so it's taken some time for us to work with customers to go build that level of confidence. But over the last 2 years, we've seen multiple companies go to production, and so we're overcoming that barrier.
It's gallium. We hear a lot of these stories about foreign countries possessing all of these very rare earth metals. Take us through the raw materials. Are there rare earth metals that are required for this? Is it less or more than what's conventionally used? Because I think there's a lot of confusion about demand and also who's supplying these materials.
The concerns you're talking about really apply to magnetics, not to power transistors. There's lots of gallium in the world, lots of nitrogen in the world. We use actually very small amounts of it in the transistors. It's not a supply concern. Certainly with the magnetic industry, that's a big concern, but not so for us.
Okay. Where do you see yourselves going? What's the next step for you guys?
Well, this is a $10 billion industry for power transistors. And about every 20 years, the industry transitions from one type of transistor to another. 40 plus years ago, it was the MOSFET. 20 years ago, it was the superjunction MOSFET, and now we're seeing this transition to GaN. So really, it's all about getting people transitioned over, building $1 billion company in sales in that $10 billion marketplace.
And you say it's every 10 years. So do you see GaN sticking around, or are you going to buck the trend?
Well, it's about every 20 years, but I would expect 20 years from now, there's another set of gallium-based materials that we might make another transition to. Ultimately, diamond is probably the best material for making power electronics out of. So maybe 40, 50 years from now, we'll be using diamond power transistors. So we're constantly going to be looking for more efficiency, smaller size, better use of our materials in power electronics. So there will be transitions in the future. But for the next 20 years or so, I think we'll concentrate on GaN, gallium nitride.
Oh, well, that's really exciting, and best of luck to you. Jim, going to finish with a lightning round of your thoughts on different energy technologies. Going to start with your thoughts on natural gas.
Clean, but still have a CO2 problem.
Crude oil.
Yeah, part of the problem, not the solution.
Nuclear.
Dangerous.
Coal.
Same category as crude oil, part of the problem, lots of CO2 generation, not the solution.
Wind.
Yep, absolutely. Renewable energy combined with efficient power electronics is the way forward in the world. So we reduce CO2, we have clean energy, wind, solar, hydro, that's the way to go.
All right. Solar. Any extra thoughts on solar?
No, part of the solution, one of the big three, renewables.
Biofuels.
Still hydrocarbon-based, and the world's got to feed itself, too. There's some competition there. Not part of the solution.
Hydroelectric.
Just like wind and solar, one of the big three.
I like that, too. Geothermal.
I like it. It's renewable. My question would be, how much of it is there? How many BTUs could be supplied for the 7 billion people on the face of the earth?
Mm-hmm. We're going to get into a couple of the families that you're working in. First one is energy storage.
Absolutely needed for balance. We need to have renewable energy, and it's not generated 724, but we use energy 724. So we need energy storage for that balance in the system.
I figure you probably also like this one, electric vehicles.
Yeah, you got it. Together with renewable energy, it's really the solution to our CO2 problem that we have with climate change.
Energy efficiency.
Mandatory for the world. We need to use our energy wisely. We need to use our raw materials wisely. So energy efficiency is super important.
And then finally, fusion power.
Fusion, I like it. Bring it on. Basically limitless clean energy, but I think it's a bit in the future, and we've got problems today. So today it's the big three of wind, solar, and hydro, and maybe tomorrow it's fusion.
Okay. Well, Jim, hopefully you'll be part of the solution too. Well, thank you so much. Jim Witham, GaN Systems, thank you so much for your time.
Jay, thanks for having me.
That was Jim Witham, CEO of GaN Systems, the next generation semiconductor company specializing in gallium nitride transistors. Another huge market segment the company is exploring, drones. I want to thank Jim for his time and Andrea Nieto with Trier Company for setting this up. You can find plenty of pictures at energy-cast.com as well as on Instagram at Host Energy. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 67. Be sure to join us next week when we discuss the opportunities and challenges of being a third-party renewable project developer. Until then, I'm Jay Downhauer. We'll see you next time.